In this video, we will see how we can solve the examples based on the Euler's method. Firstly, we will see the Euler's formula and then we'll solve an example based on the Euler's method. The Euler's formula is yn plus 1 is equal to yn plus h into f of xn comma yn. Let's solve an example. Solve dy by dx is equal to x root y of 1 is equal to 1 and find y of 1.5 by taking h is equal to 0.1 using the Euler's method. Here we are having dy by dx equal to x root y, which is our f of x comma y. Then we have y of 1 is equal to 1, which means x0 is equal to 1 and y0 is equal to 1. And we have h equal to 0.1. We need to find y of 1.5, which means x is given to us 1.5. Now here the first step will be to find the number of steps. Formula is n is equal to x minus x naught upon h. X is 1.5, x naught is 1 and h is 0.1. So from this we get n equal to 5, which means we'll go up to 5 steps. Starting with the first step, x0 will be 1, then x1 will be equal to x naught plus h, which is 1 plus 0.1, that is 1.1. Then x2 will be 1.1 plus 0.1, which is 1.2. x3 1.2 plus 0.1, that is 1.3. And x4 will be 1.3 plus 0.1, which is 1.4. Now we'll find y1. y1 will be equal to y0 plus h f of x0 comma y0, because the general formula is yn plus 1 is equal to yn plus h f of xn comma yn. y0 is 1, h is 0.1 and f of x0 comma y0, which is that will place in x root y. 1 plus 0.1 into f of 1 comma 1 is equal to, here we'll place it 1 plus 0.1 into x root y, which is 1 root 1, and this will be equal to 1.1. This is y1. Then we'll find y2. y2 will be equal to y1 plus h f of x1 comma y1. Now we are having all of the values, which is x1 is 1.1, y1 is 1.1, h is 0.1. So 1.1 plus 0.1 into f of 1.1 comma 1.1. Again we'll place the values of x and y in this x root y. So this will be equal to 1.1 plus 0.1 into 1.1 root 1.1, and y2 we get it equal to 1.2154. Same way we'll find y3. As we have got 5 steps, so we have to go till y5. y3 will be y2 plus h f of x2 comma y2, and x2 is 1.2. This will place here. My y2 I have got it as 1.2154 plus h is 0.1 into f of 1.2 comma 1.2154. That will be equal to 1.2154 plus 0.1 into 1.2 root 1.2154, which is we are placing it in x root y. and on solving this we'll get y3 equal to 1.3477. Then we'll find y4. y4 will be equal to y3 plus h f of x3 comma y3. Value of x3 is 1.3 and y3 is 1.3477 plus h is 0.1 into f of 1.3 comma 1.3477. Again the same thing, we'll place x root y. So this will be 1.3477 plus 0.1 into 1.3 root 1.3477, and this we get it equal to 1.4986. Then we'll find y5. y4 is 1.4986 and x4 we are having 1.4. From this we'll find our y5. y5 will give us y of 1.5. y5 is equal to y4 plus h f of x4 comma y4. 1.4986 plus 0.1 into f of 1.4 comma 1.4986. f of x comma y is equal to x root y. We'll place it 0.1 into 1.4 root 1.4986. This we get it equal to 1.67. This is the value of y of 1.5. Here I'll just write it, that my y5 is equal to y of 1.5 is equal to 1.67. This is how simple it is to solve the ordinary differential equations using the Euler's method. The only thing is you'll need to remember the formula, then solving the whole example is very much simple. In the next video, we'll solve the example based on the modified Euler's method. Thank you.